So yesterday you completed a plane you can't fly task on pages 2 through 5 in your packet. This was basically your introduction to complex numbers, and it actually did everything that we are doing today. You converted from rectangular / standard form to trig / polar form within that task. You may not have actually known that was what you were doing, but now I'm kind of putting it all together into a lesson so that if there was something in the task you did not understand, you should now be able to go back after this lesson and look through that task and be able to complete those problems. So one of the things you learned yesterday was that when you're graphing a complex number, okay, we're graphing on the complex plane. So the horizontal axis is your real axis and your vertical axis is your imaginary axis. So if we're graphing 3 plus 4i, like this problem says, 3 plus 4i, that's the same as a plus bi, remember? And so your real part is the 3 and the 4i is the imaginary part. So it's just like you were going over 3 and up 4. So you go over 3 on the real axis, and then you go up 4 on the imaginary axis. Absolute value. We talked about absolute value in the task, okay? What you should have noticed, guys, is that the absolute value is the same thing as magnitude. When we talk about the absolute value of a complex number, so absolute value of a complex number, okay, is the square root of a squared plus b squared. And if we look at that graphically, okay, you have this triangle that went over 3 on the real axis and up 4 on the imaginary axis, okay? However, if we want to figure out Hedwig's flight, okay, or if we want to talk about how far Hedwig the owl flew, we need the length of the diagonal, okay? And guys, that is known as the absolute value. Remember, by definition, absolute value is your distance from 0. So we're trying to figure out the absolute value of this complex number. It's distance from 0. So in these examples, it says graph the complex number and find the absolute value. Now, we're obviously not going to do all of these, but let's look at this one. If we're doing 4 minus 4i, okay, we're going to graph it first. So 4 minus 4i. So on the real axis, we would go over 4. And on the imaginary axis, we would go down 4. So that is my 4 minus 4i. Okay. So now, if I want the absolute value, remember, by definition, absolute value is really just our Pythagorean theorem, or the same thing as magnitude when we were talking about vectors. So if I want to do this problem, if I want to find the absolute value of z, I am going to do the square root of a squared, so 4 squared, plus negative 4 squared. And when we type that in our calculator, we are going to actually get the square root of 32, okay, because 16 plus 16. And then we're actually going to go further, okay, and remember we have to simplify our radical. So this is the square root of 16 times the square root of 2, so it's going to be 4 square roots of 2. That is the absolute value of v, okay? So that would be our first example. Now, let's look if our complex number is just negative 5. So what if I have z is negative 5? What is that one going to look like? So what we need to look at here, if z is negative 5 is your real part. That's like negative 5 plus 0i. So if I look at that, my complex number is just right here, negative 5. So if I want the absolute value of that, I'm going to do the square root of a, which is negative 5, so the square root of negative 5 squared, plus b, which is 0. So that's going to be the square root of 25, which is just 5. So y'all, the absolute value of z is just 5. Now check that out. Absolute value is defined to be the distance from 0. Well, look, it's 1, 2, 3, 4, 5 from 0. So wouldn't that make sense? So we could go through and do the last one as well. But remember that absolute value really is nothing different than magnitude, or your distance from 0. So now, trig form of a complex number. This is where things get a little bit crazy. So we're going to look at our same complex number, a plus bi, okay? And I want us to go back to our SOHCAHTOA, okay? And if we look at SOHCAHTOA, all right, if we want to look at cosine of theta, remember cosine is adjacent over hypotenuse. Theta is standing here, so adjacent would be A, and R would be our hypotenuse. That's where our cosine of A equals A over R comes from. And then sine is opposite over hypotenuse, so sine is B over R, so that was this one. And then we just solve for A and B, okay? Where A is R cosine of theta, and B is R sine of theta. Biggest thing that's new to this is that absolute value is also known as R. So in both of these problems when we did this, we could have said that R is 5. So we need to remember that absolute value is R. Okay, so A is going to be your absolute value times the cosine of theta, and B is absolute value times sine of theta. So what does that mean for us? If I take that A and B and I put into my A plus BI formula, this is my result. Z equals R cosine theta plus I sine theta. Now this is something that was introduced to you in the task, and this is something that you should be familiar with, okay? But here is the reality of the situation, okay? We have two forms. We have rectangular form, okay, which is also known as standard form. Oh my gosh. Okay, I don't know what's happening to my letters. Okay, so what you're going to notice and you learn from the task is that you have rectangular form, which can also be called standard form. Those are interchangeable. That is what you're always accustomed to using, where you've always seen A plus BI. Then we also have trig form, which can also be called polar form, okay? That is Z equals R cosine theta plus I sine theta. And then remember you saw in the task, and we've taught before, that mathematicians sometimes don't like to write it all out. So this is the same thing as saying R cis theta, okay? So R cis theta is just short for R cosine theta plus I sine theta. So what we're going to do today is we are going to change from rectangular form, otherwise known as standard form, to trig form or polar form. Now what we need to know is that R is also known as your absolute value or your magnitude from the last unit, and theta is known as your direction from the last unit, or you learned from the task it's also called your argument. So we are going to use this today. So given the complex number -2 minus 2i, so we're doing this problem, -2 minus 2i, I want you to write it in trig form. Now I'm telling you, write in trig form. What does trig form mean? That means R cosine theta plus I sine theta. Okay? In order to write it in trig form, you have to have an R and you have to have a theta. So what we need to do first is we need to look at this graphically. Okay? And -2 minus 2i should be right here in quadrant 3. Okay, so we need to make sure when we find our theta that we find our angle in quadrant 3. So let's start with R. So R, remember, is absolute value, also known as magnitude from before. So R is the square root of -2 squared plus -2 squared. So the square root of 4 plus 4, so R is the square root of 8. And then remember, we need to reduce our radicals to 2 square roots of 2. Now for theta, you did this in the task. Remember, when we were looking for direction in our last unit, you used our tangent of theta equals B over A. That's exactly what we are going to do here. So we're going to say that tangent of theta equals -2 over -2. Well, guys, this is a non-calculator unit. So most often you're accustomed to picking up your calculator, typing in inverse tan, and then getting your answer. Well, you're not going to have a calculator. So right now, I have that tangent of theta equals 1. And I have to figure out, what is my theta? So the only way to do this without a calculator is to go to our handy dandy unit circle. So I need to go to my unit circle. I need to figure out where the tangent is 1. And then I got to be careful because I have to make sure where is the tangent 1 in quadrant 3, because we graphed this in quadrant 3. This complex number lies in quadrant 3. So we're going to go to our unit circle, okay? And we're actually going to look at where is my tangent? Where is my tangent 1 in quadrant 3? So remember, it's helpful to go through and label your tangents. So pi over 6, remember, square root of 3 over 3. Pi over 4, tangent is 1. And then pi over 3, the tangent is square root of 3. And then we go through and repeat all the way around. So what we know is that the tangent actually is 1 at 5 pi over 4. Okay? So the tangent is 1 because I need to be in quadrant 3. And the tangent is 1 in quadrant 3 at 5 pi over 4. Okay? So in this case, my theta is going to be 5 pi over 4. So now I have the ability to write my answer in trig form using my r and my theta. So I actually can say that z equals r, which is 2 square roots of 2, times cosine of theta, which is 5 pi over 4, plus I sine 5 pi over 4. And y'all, I just converted from standard form to trig form. Now, again, if you're a shorthand person, you can write 2 square roots of 2 cis 5 pi over 4. Those are the exact same thing, and there's nothing wrong with that answer. Okay? So we're going to do one more just to be sure we know what we're doing. So we're going to do this example right here with some radicals, okay? Just because sometimes that gives people trouble, all right? And I want to make sure we know what we're doing. So it says we're writing it in trig form. If we're writing it in trig form, remember you need two things. You need r and you need theta, okay? So let's find r first. So when we go to find r, move this up here so I have some room. All right, so when we go to find r, we're going to say that r is the square root, okay, of the square root of 3 squared plus 1 squared. Notice b is 1 if there's nothing written in front of the I, okay? And remember, you're not going to have a calculator, so we're going to have the square root. And then you have to know that the square root of 3 squared is just 3. Remember, when you square a square root, it goes away, plus 1 squared, which is 1. So we're going to end up with the square root of 4, which is actually 2. So that's my r. Then we're going to do theta. So we're going to say tangent of theta equals b over a. So that's 1 over square root of 3. Well, remember, not allowed to have radicals on the bottom. So we're going to get that the tangent is square root of 3 over 3. So now I've got to go looking at my unit circle. But before I can, I've got to know what quadrant I'm in. And what quadrant is this complex number in? If it's positive, positive, it means you're going to go over square root of 3, which is a little less than 2, and then you're going to go up 1. So we're somewhere in quadrant 1. So we're going to go to our unit circle in quadrant 1 and look for where the tangent is the square root of 3 over 3. So if we're looking in quadrant 1, tangent is square root of 3 over 3 at pi over 6. So then my theta would be pi over 6. So for our final answer, we're going to substitute into trig form. So we're going to put r, which is 2, and then we're going to do cosine pi over 6 plus I sine pi over 6. And that is going to be your answer. And again, if you would prefer shorthand, you could do 2 cis pi over 6, and that is the exact same thing. So when we're going from standard form to trig form, remember, you've got to have an r and you've got to have a theta. R is no different than the last unit with vectors. R was magnitude, now it's called absolute value. And theta used to be called direction, and now it's called the argument. But either way, the formulas stay the same. So now, for your homework, you need to be completing page 6 in your packet. The first 4 questions have you just finding absolute value, pretty basic, and then the next ones have you actually converting using your unit circle. And then remember, you're going to be given a unit circle on your quiz or your test. So you will not have to worry about memorizing it again. You just have to know how to use it.